Hi, we're now going to talk about an important topic in C programming called pointers. And pointers are one of the main reasons why C is still holding very strong as the most preferred language, for many embedded applications because of the way it is able to map very closely to hardware, memory, and registers. So this is an important topic that you must know, especially when you are dealing with hardware in the future. Okay, so let's understand a bit of, again, memory allocation. So when I declare a variable such as num, for example, this num would be allocated anywhere in memory. Where it is, we do not know, and every time I compile it, it may be allocated to some other new memory location. So it all depends at the moment of compilation. Now, when I do assignment, so I say num equals to 2, and I do a printf, for example, then what do I get? I will be able to print out whatever value is currently stored in num. So this is very basic. We already know that. So let's just compile and run this. So in this simple example, we have done nothing more than declare a variable, assign it a value, and print out the value later on. Now, this memory that has been allocated to num is currently referenced through this variable name called num. So the name is directly sort of linked and mapped to the memory that it is allocated to. How do I know the actual memory location? That means in the full address range. What I can do is I can do a printf of the address. So how do I do that? So I can say address of num. So when you're doing printing addresses, you should use the identifier %p because that will print out the value as a hexadecimal. Why is it hexadecimal? Why is hexadecimal preferred? Is because your addresses can be in the range of 32-bit or 64-bit, and when you print out the hexadecimal, it's a lot more readable, and relatable, especially later on when you're talking about incrementing your pointers or arrays, that we will see later. For now, let's stick with %p as the preferred option for printing addresses. How do I print the address of a variable? It is the same concept that we use in scanf. When we did a scanf, we use the ampersand sign before the variable name. So that is the same thing we need to do here. So I need to say ampersand, the variable name here. And what it will do is it will print out the address where this num variable is stored. So let me compile and run again. And you can see that this is the value and this is the address. So this address is based on the whole memory that this system, that is this current PC that I'm using, the whole memory that I have, it has allocated this memory location to hold this variable num, and the data inside this memory location is currently 2. Now with pointers, how do I declare pointers? To declare pointers, I declare the type that it is supposed to point to. So if I want the pointer to point to an integer, then I declare it's an integer pointer. So I say integer, and the variable name must be must start with a asterisk. Must start with the asterisk sign followed by whatever variable that you want to give. So for example, in this case, let me just call it pnum. There's a pointer to num. You can give any name, doesn't matter. So I'm just going to call it pnum. So pnum is now a pointer that has the capability of pointing to any integer variable. How do I use pnum now? So the important thing about using pointers is before you use it, you must make sure that it is pointing to the address of the variable. You must point to the variable that you intend to point to, and to do that you must say, or you must assign the address of that variable to the pointer. Okay, so let me repeat that again. The first step is you declare a pointer, okay, and this data type should be the type of data that you want this pointer to point to. And once I declare the pointer variable, I must assign the pointer to point to the variable that I want. So if I want pnum to point to num, I must assign the address of num to this pointer here. And once I do that, okay, you will see that the address that pnum will now point to exactly where num is. Okay, and how do I get this information? I can print out. Okay, I can do a printout of it and say that value pointed by pnum equals to %d, and what I'm going to put asterisk pnum here. Okay, so whenever I use asterisk in front of the pointer name, it is going to reference the actual value. If I just use the variable name without the asterisk, then it is the address. Okay, so let's print out the value followed by the address also. Okay, printf address held by pnum equals to %p pnum. Okay, so pnum is holding the address of num. So I would expect that this line and this line to be the same. Okay, that means they should both display the same value. And again, this line and this line should also display the same value. Okay, so let's run this. Okay, so you can see that, okay, value of num is 2. Value pointed by pnum is also 2. Why? Because pnum has been assigned to the address of num. Okay, and whenever I use asterisk, I'm referring to the value that is inside that address location. If I just use the pointer name without the asterisk, then it refers to the address that I'm currently pointing to. Okay, and this address is actually the address of variable num because I've done the allocation here. Okay, that is why you see this and this to be the same. Okay, since pnum is a pointer to an integer, it can also mean it also means that pnum can be used to point to any variable that you want. Okay, so if I have another variable, okay, called for example marks, okay, and I say that marks as a value of 5, okay, I can choose to later subsequently reassign pnum to point to marks. Okay, again, how do I assign the pointer to point to a particular variable? All I need to do is to assign the address of that variable to my pointer. Okay, and once that is done, let me reprint these two statements here. Let me do one more. After marks assignment, do pnum. Okay, so let's run this now. Okay, so what do you see here? You see that the first part is still the same, but subsequently after I assign pnum to point to marks, now the value pointed to by pnum is 5 because marks has a value of 5. Okay, so that is the powerful element of pointers. You can assign pointers to point to any memory location that you like, and you can see that this memory location, this address held by pnum, is different now compared to the earlier assignment to pnum. Okay, why? Because originally pnum was pointing to the num variable, and now this pointer is now pointing to the marks variable. Okay, and each time you declare a variable, the compiler is going to give you a unique memory address where this variable will be stored. So that is why num is stored in this location while marks is stored in this location. Okay, so this gives you some idea, correct, on basic concepts of pointers. Of course, there are a lot more things in pointers and why we need it. Okay, so we will come to that later on, especially when we are talking about function returning multiple parameters to a caller function. Okay, so that is one of the key areas where pointers will be will prove to be an advantage. Okay, so that's it. So we will see you again in the next video where we talk about more C programming topics. Thank you.